Good morning, friends. This is Dr. Faisal. This is Dr. Faisal speaking, and I'm going to tell you about the subject in that is manufacturing processes, and the topic for my discussion will be cupola furnace. Okay, so what I'm going to tell you is a cupola furnace is a furnace which looks like this. You can see here in actual conditions there are three zones on the top and one zone on the bottom, and this is used to melt iron and other metals so that into molten state, and it can be given any change in shape which can be changed. And we have this heating media. What is the furnace? First of all, I will let you know that it is a heating media or device used for heating and melting, and for providing heat to chemical reactions and processes like cracking. The furnace may be heated by fuel, and as in many furnaces, coke is being used. We use fuel to get heated to heat the furnace and furnaces. Some are operated by electrical energy, for example, electric arc furnaces. So these are the techniques which we are using it, right? And the other point is cupola furnace. It was made by Reni Intoni, as you all know that, and it is a melting device and for used for making bronzes in the previous in early ages and in earlier times. And cast iron was mainly used, and like coke, metal, flux. These are the things which were used to be melted in this cupola furnaces. Scrap of blast furnace is remelted in cupola. Large cupola may produce up to 100 tons per hour of hot iron. So these are the basic things we should know about the cupola furnace. Now about its construction. It is a cylindrical in shape and placed vertical. Its shell is made of steel. Its sizes expressed in diameters, that is 0.5 to 4 meters, as per our requirement. It can be made. And it's supported by four legs. Internal walls are lined with reflective bricks, which is a very important thing, reflective bricks. Otherwise, heat will be flow out of the body, and its lining is temporary. Thirdly is heating media or the device used for heating and melting, for providing heat to chemical reactions, for processes like cracking, furnaces maybe. These are all things. Then this is the other thing, cupola furnace is construction and working. So this is how it looks like on the top you can see the spark arresters, which is in here. This is a steel shell. Then we have this metal bodies. Here we store metal charging door from where the metal has been integrated, and this upper zone is called stack zone. Then we have where the metal and flux and coke has been kept, that is called preheating zone. Here preheating take place by the gases already coming out from the two airs, that melts it, that would get through which it gets preheated. Then we have a melting zone. Here at this point, at the lower, the metal gets melted up, and you can see here that metal flux coke. These are the layers in which it has been placed here. Metal flux coke, and in this manner it has been kept here. This is the melting zone, and this we have a reducing zone. Here, metal is being converted into liquid state, solid to liquid state changes. And there is the slag hole where all the impurities get pushed out here from the backside. And here we get a tap hole where the molten metal in its form we get it out. And these are the furnace legs, which we can see here from the top, from this side as three side. And this is the sandbag where these are metal has been removed, and in this way the direction has been given to it. Okay, so this is basically construction, which is a very important factor there. Then parts of a cupola: spark arrestor, charging door, earbox, two ears, tap hole, slag hole, and its importance. Look, these are the zone. Well is called this lower portion. You can see here it's called the well. The space between the bottom of the two ears and the sandbag, molten metal collected in this portion. Most of the molten metal is collected in this portion, this well. Below the two ears is called well. Then combustion zone. This is basically a combustion zone. We can see here about the well. Yeah, also known as oxidizing zone. Combustion takes place in this zone. It is located between well and the melting zone. Height of this zone is normally 15 to 30 centimeter. You can see here. Then third of the zone is in this zone, the temperature is 1540 to 1870. This temperature range we should know it. There's a basic thing. And what are the chemical reaction which has been taking place? That is only we can see here this exothermic, where heat is been coming out from the reaction. That is C plus O2, the CO2 plus heat. Heat means heat is coming out, that is exothermic. Endothermic means where heat is taken out. So only exothermic reaction taking place. Silicon plus oxygen, SiO2 plus heat, 2M plus O2, 2MO plus heat. Reducing zone locate between upper layer of combustion zone and upper layer of coke bed. Upper layer, that is the reducing zone. You can see here. This is a small. You can see here. This is a reducing zone, a small reducing zone here. You can see in the figure where the arrow is going on. Then the third one is other zones are reducing. This other zones are melting zone. In this zone, the melting is done. It is located between the preheating zone and combustion zone. The following reaction take place are iron plus carbon dioxide will get Fe3C plus CO2 if you are using iron and carbon and coke been used, and carbon monoxide has been removed. Now the working of this furnace you can see here on the right figure. Here scrap, alloy, coke and limestone has been added into it. Its charge consists of scrap, coke, and flux. The charge is in the place layer by layer. We can send it by layer, metal and coke and flux, all it put into it, and it gets automatically heated from the bottom. When it gets heated up from the gases, burning gases, and metal becomes liquid and it comes out, and so on and so forth. The things are the first layer of coke, second is flux, third is the metal, as we have discussed earlier. This increases the energy efficiency of the furnace. And lastly, advantage and disadvantages. It is a simple and economical to operate. Cupolas can refine the metal charge, removing impurities, outer slag, high metal rates, ease of operation, adequate temperature control, chemical composition, efficiency of cupola. These are the basic advantages in cupola furnaces. Okay, it is simple and economical. Cupolas can refine metal charge. Then disadvantages, molten iron and coke are in contact with each other. Certain elements like silicon, magnesium, and most of the like sulfur and picked up. The sulfur gets also picked up in this case. Hence, the final analysis, which changes the analysis of the molten metal, and we get impurities also get burned. Now, close temperature control is difficult to maintain. That is one of the major disadvantages. That's all for cupola furnace. Thanks.